How's it going, everyone? Welcome. Julian Gonzalez here, and today let's going to continue of the preface of about what is JavaScript from the book You Don't Know GS Yet, made by Kyle Simpson, a software engineering that has previously worked at several companies and startups, and now he published this second edition of this book with, I think this is important from the historical perspective in terms of understanding how do we get here, so we can have now a much better experience when it comes to solve problems using JavaScript, right? So understand the spec behind that, who made this, who is the author, so we don't now, as JavaScript developers, neglect or be reckless or blame how things works in JavaScript to the language, where the reality is that most of us that do that is because we don't understand how that things work. We don't understand the mechanics. We don't understand is how do we get here, so people like you and me can get paid from developing JavaScript applications. So I think this is quite interesting. And so far we went through describing is this particular first section about this book, that this is for this is a non-beginner JavaScript book. Instead, you must have experience on the language, so you can start to understand how all of these things starting to make sense. Now, what was with the name? All right. So what is with that name with the JavaScript? The TLDR is that so JavaScript is a marketing. So the term JavaScript is a marketing shenanigans. So since this particular script was created by Brendan H when he was working at Netscape, the first commercial browser, all right, and internally he codenamed that as Mocha, and then at Netscape they know that script as LiveScript, and because the marketing team say we want to now targeting is Java audience where they have a lot of experience to do that by telling them that this is now a lightweight version of the language, aka so this is now a Java script. So the thing here is that it was targeted to those developers and make some assumptions that whether you are a Java or a JavaScript, you must have notions of how you write C programs, because a lot of the syntax actually are related. But that's the only, but the similarities reach to that. Now, when you look at the legal aspect of the language, which the trademark, that because now it belongs to Oracle via Microsoft, and Microsoft was a company that acquired Netscape in 1998, November 1998, and then in 2009, 11 years later, Oracle acquired is Microsoft, which is some Microsoft that owns JavaScript via the acquisition of Netscape. So all of these chains, and you can see how now not only the technical aspect, the computer aspect of this, or the language, is involved in the real life problems, such as the market bubbles that happen not only at the .com, which is circa 2001, but also the the house bubbling in 2008, right? So this kind of market crash is something that we have experienced before a lot of the time. All right, perhaps now we have this more intrinsic in skin on the game. If you're born in the 90s, so you will know very well about that. Depend of the city you live. In my case, Venezuela, we were living a bubble, so that .com doesn't affect us that much. All right. But well, the socialists begin and came, and well, here I am in Argentina. So, but the point of this is understanding now this legal aspect about the technical language, in that despite that you call it JavaScript or GS, at this point, Oracle never, in not even AOL, has enforced the trademark, and at this point is quite less likely that happen. So the other is the specification, which is the technical aspect. All right, we talk about the legal aspect. Now is the technical aspect. So the spec ECMAScript. Now this is the name known for a group of people, the TC39 commit, that gather together, where they do some meetings to evaluate the current state of the spec, and that match with the current state of the web, of the reality of the web, right? And despite how do you name this, whether it's JavaScript or ECMAScript or GS, and also it is important to not use terms like GS6 or ES8. In fact, it's used a notation of ES and the year where that specification was launched. Okay, so I think that there is a good quote that says that Java is to JavaScript like ham is to hamster. Exactly, exactly. So this 30 TC39 commit, all right, which is the language specifications. It is a bunch of people that come from a variety of industry or web industry, whether it is browser makers, device makers, so on and so forth. Some of those are now or receive some sort of compensation from the companies they work on to go and assist to this meeting, and those meetings are usually hosted by a company. So the companies are the one who decide to do that. Now, because this group, the TC39, has a particular methodology to evaluate its individual champions or individual proposals. Any proposals that are not part of the meeting is known as a pre-stage 0, and this stage go from 0 to 5 to 4. All right, so as a programmer we started to count from 0, okay, and they meet bi-monthly, all right, usually 3 days. And when those proposals now get into that meeting, a lot of people can contribute to the discussion of that through their GitHub peer, but it is up to then the TC39 commit to decide which specs are actually going, or champions, proposals are going to pass through this stage. So those champions that pass through or wait work out until stage 4, when can take up to several months to several years to evaluate that. Now, when they reach at that moment, it is, even though, all right, when they reach at that moment, they now are a candidate to be implemented in the language, in the proposals as well. So why am I mentioning all of this? Because this is to understand that they also have this commit has a huge impact on how we're going to now work with this tool. So they are now the responsibles to design the new feature that we're going to implement into the language, right? One of the great things of this is that despite that we have several JavaScript engines, all right, and since major browsers actually follow the specifications, but they don't implement that, but they implement these features at different times, this doesn't mean that the JavaScript Chrome engine implement an incompatible or different features from another engine. Let's say Chakra or Mozilla JavaScript engines, right? Or the Safari engine, which is something that React Native applications are using behind the scenes. Is using this particular engine, the JavaScript core. Why is that? Because, well, due to the restriction that Apple has of V8 engines or other JavaScript engines, right? So this is the reason why the React Native team, which is part of the Facebook, aka or Meta, right now they actually has that, right? So you may wonder, okay, good for all of this, but when it comes to understand that since we can run now JavaScript in any environment, all right, and do these environments now grows, so we can run now JavaScript in different places, not only the browser, but on the server with Node.js, but in robotics and Libel, so on and so forth. Now, the specification, okay, or the way how JavaScript is implemented, it takes the reality of the web, and that is all that matters. And to me, this is quite interesting. How do you know about this? How do you know that the reality of the JavaScript engine, or the reality of, so despite having these large collections of environments, how do you know that JavaScript, the only reality that matter is on the web? All right, this is to me interesting. This is to me quite interesting. This is to me quite interesting. Mm-hmm. So based on the following text, for real, where is this statement are coming from? Well, the rest of the environment runs. The one environment that will just is the web. Oh, look at this! Look at this! How it's doing that? How JavaScript implement web browser in a practicality on the only reality from browser to server, node robots and to lipo. JavaScript environment robot lipo. I wasn't able to find a specific source of this quote through web search. The text appeared to be discussing JavaScript dominance, web environments, despite its expansion and others. JavaScript programming books or tutorials, web development blogs or articles, technical documentation, programming course. The quote reflects a common perspective in JavaScript community about how web browsers implementations effectively drive JavaScript standards and practice. If you have more context where you encounter this text, I encountered. I find it on the book You Don't Know GS Yet, second edition. Second edition. Through the exploration, exactly. Mm. That's something. That's something that perhaps go beyond here. It was create international additional features, all right. But the thing is that the exploration that Kyle Simpson actually made, the author of a particular book known as You Don't Know GS, is based upon that, right? That despite that all of these environments that we have right now, the one that rules all JavaScript is the web. So how JavaScript is implemented for web browser in the reality is that, or in practicality, that's the only reality that matters. And because of this, okay, since for most part the JavaScript specification is defined in JavaScript, and the JavaScript that run in the browser's engine follow the spec, sometimes the JavaScript specification will dictate a particular behavior that won't match exactly not only how web browsers works, but also the reality of the web. All right. Despite that, this JavaScript engine has more than 20 years, and since some of them actually follow the specs, well, whereas there are some times that JavaScript engines, exactly, there's some times that some JavaScript engines refuse to follow the specifications, doing the reality of the web. In other words, it will break some particular websites out there. So a good example of that is, for example, the TC39 wants to add the contains to array as a way to find that elements, right? But because there is a particular library that uses that, and it sometimes is somewhat common, and to avoid any conflict, they change that to include. And the other is the same happened with the comedic tragic JavaScript community crisis known as Smooshgate. that's quite interesting if you want to dive deep into this. But the TLDR is that the uh, TC39 members plan to launch is flattening, okay, as the as a method for the arrays, and because again a particular library that was using for a certain amount of websites in Germany, I think it is. So they have to rename that to the flat, because not only that the particular language use flattening as as their array prototype, all right, but also that when they do that, they actually were manipulating is some DOM elements. So this cascading effect in those web apps or web content that were using that library, of course they will be affected by that. So the TC39 have to gather, they have to meet quickly and see, hey, you know what, we have this particular problem. Let's go in, let's to avoid this champion. Let's go to rename this champion, this proposal, to flat. you know. But occasionally, now TC39 will decide the specifications and point out that some JavaScript browsers must confirm. So, and what happened when they don't? Okay. Occasionally TC39 will decide a specification and should stick firm on some points, even though it is unlikely that JavaScript browser's engine will ever conform. So what happened when despite that the TC39 say, I want you as a JavaScript engine maker to confirm with this, but some browsers are unlikely to do that, the solution to that is drop the spec and follow their own, or just stick to a particular section, appendix B, all right, additional ECMAScript feature for the web, where that include is the details of any known mismatch between the official JavaScript specification and the reality of the web. That's quite interesting. That's that appendix B here, it mentioned that additional ECMAScript features for web browsers. That's mind blowing, bro. Okay. Makes a lot of sense. Makes completely a lot of sense. All right. This is the solution here. So the solution for those JavaScript engines that are unlikely to conform to the TC39 and the ECMA spec is that additional appendix, appendix A, appendix B, which is additional ECMA script features, where they now highlight is the detail of the mismatch between JavaScript it highlights the difference between the JavaScript specifications and the reality of the web. That is well, again, TC39 was born way after JavaScript engines even appear. So because of that, and the reality of the web are something that is different from what the ECMA spec actually is, all right, and I think that's quite relevant and important to know. For example, that is that when we talk about the JavaScript, so not all JavaScript are the web. And a good example of this is when you want to now run specific JavaScript functions, all right? For example, like the alert, or like the fetch, or like they get current locations and user media. So despite that, whether if you are now running JavaScript in different environments, each different environment now have a specific behaviors of JavaScript. So those environments, which I think it is quite important to know, right? So for example, on the web you have now the fetch, they get current location, and they get user media. Whereas in servers you have now write file or write sync. Okay, if you want to write or read a file synchronous, and I brought that is this inconsistent because that's also something that is replicated to the consoles or to the relp. All right. it is not always it is not always JavaScript. Oh yeah, to do that. So using the console or the console of the relp in your browser's developers or Node feels like a pretty straightforward JavaScript environment at first glance, but it's not really. Developer tools are tools for developers. Their primary purpose is to make life easier for developers. They prioritize developer experience, and it is not a goal of such tools to accurately and purely reflect all the nuances and strict spec JavaScript behaviors. As such, there are many quirks that may act as a gotcha if you're treating the console as a pure JavaScript environment. This convenience is a good thing, but the way exactly this convenience is a good way. By the way, I'm glad developer tools make developers' life easier, and I'm glad have nice UX charms like autocomplete or variables property, etc. I'm just pointing out that we can and shouldn't expect such tools to always adhere strict to the JavaScript programs are handled, because they are not the purpose of this tool. This is one of the reasons why we are getting here, is that after we went through all of this, so the history of the JavaScript, and exactly. So after we went through the history of JavaScript, who made this, in what was the name that they were using back then, and how now the JavaScript popularized that thanks to the marketing teams that target these Java developers with this lightweight alternative that you must know, or it makes some assumptions about the developers that they must be quite familiar with writing programs in C, or this C syntax like. So for example, like block. And we also look at the legal aspect of this from Oracle, that now owns the trademark via Sons, and Sons acquired Netscape, and Netscape was was the first commercial browsers that developed that particular tool, which is the browser and the language in itself, all right, which is JavaScript, thanks to Brendan H. So Oracle hasn't enforced this trademark, and to this point, it's very unlikely that it can do that. However, because this is now how the language is known legally, and on the technical aspect is known as the ECMAScript, which is the language specification, and how this language, despite that you name it JavaScript, and EX6, and how important it is to, from the 2019 or 2016, call EX and put the year of the specification. And you may say, hey, yeah, but this is boring, blah, 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 blah. Again, we are here to be serious about it. We are here to actually dive deep and explore and to understand how all of the things works. So when we need to understand why a particular feature comes, we know that, we know where it comes from. We know the source of this. So This is why the language spec is now ruled by the TC39, which is a group of developers and people that works in a variety of web-related industry, such as the browser makers or device makers, so like Samsung, and they, mm, uh, so they, so they make, so they meeting bi-monthly, usually 3 dates. Yeah, in uh, they now decide which proposals are going to be approved. So, despite that you can contribute to that, which is open source, right? So everybody can contribute into the discussion and propose any of these champions or proposals. All of these are known as the pre-stage zero, and because now the commit has this series of stage that a champion needs to pass through it, all right, to be accepted. And once that champion uh, goes up through the ranks up to the stage 4. So this stage are something that the TC39 design that go from 0 to 4, because we're programmers. Programmers starting to count by from 0. That's the reason. So this process can take several months up to several years when that happens. And not only that, that the developers, or let's say the specifications that are enforced by the commit, so this, because now those JavaScript can run in a variety of environment, not only on the web, but also on the server, but also on the robots and light bulbs and yada yada yada. So the reality that matters for JavaScript implementations is the web, and because sometimes JavaScript engines, so JavaScript engine must adhere to the spec, but sometimes they can skip this adherence to the specifications to the reality of the web. So this reality, the web reality, which is something that browsers that has been over or JavaScript engine that has been over 20 years plus, okay, in browsers can decide to not adhere to some spec of the they can decide to not adhere to the spec of that. So a good example of is the TC39 wants to implement the contains array, the contains method into arrays, right? Let's see if that actually is. Let's see if these elements is contained in this sort of elements, all right? And because that it was used by a particular framework that has somewhat percentage on the web, so JavaScript engines decide to JavaScript engines in collaboration with the TC39, they decide to rename that and call that includes. All right. And another good example is something known as this Mushgate. That was a comedy, tragic, something that happened in the JavaScript community, where again that was somewhat similar to this, where they want to now implement a particular methods for arrays called flatten, but that was used again for a particular framework in Germany that somewhat serves some yeah, that serve somewhat um, several websites, okay. And not only that, is that that particular feature that that framework implements not only modify the JavaScript behavior but also the DOM elements in it itself. So there was a cascading effect that happened here. So they decided to change or to rename that from flatten to flat. So these examples here is just to make sense, to understand that when you are going to look at JavaScript as well as the JavaScript environments and the TC39 and JavaScript engines, is to recognize this nature, is recognize this social aspect of the language, and that those that despite that, even though that TC39 enforce or uh, it indicates that JavaScript engine must conform to the law, right? Those JavaScript engines are unlikely to implement that due to the nature of the web. So they have now an appendix B, that calls these additional features in JavaScript, additional ECMAScript features from the web, where they describe is the mismatch between the JavaScript spec and the reality of the web. So because of this mismatch, okay, in that when you are running your JavaScript code, and I want to use that mismatch to enter into this realm. When you define that mismatch, and when you now entering into the realm of writing JavaScript code in different environments, and you realize that on the web you have now a specific set of prop methods that you can have access. For example, alert or fetch data from a server, or send data to a server, or get current locations, so to actually communicate to the hardware of that machine, or whether it's a laptop or mobile, and to get now the location of that, or the user media. So all of these are relevant for the web. And the other is, for example, in servers you have now file sync, or read or write a file, synchronous or asynchronous. So because of this mismatch that happen, is most of the time is on the JavaScript developer's mind, because they don't understand where they are writing their code, and they blame to the language for being poorly designed. It is important that this inconsistency is based on the environment. So not only that those inconsistencies are based on the environment, it also that when you're using now read, which is another place to use JavaScript, another environment, sort of speaking, that runs JavaScript. For example, the read event print loop, or the console. So because the developer tools is a tools to help developers to make it easy their life, their console was not purely accurate and defined to implement JavaScript purely. So this convenience is a good thing. And by the way, I'm glad developer tools make developers my life much more easier, okay, with a nice UX, autocomplete, and variables, and all that kind of stuff. But I just point out that we can and shouldn't expect such tools to always adhere strictly to the way JavaScript programs are handled, because that's not the purpose of this tool. And since such tools vary in behavior from browser to browser, and since they change, sometimes rather frequently, I'm not going to hard code any of the specific detail into this text, thereby ensuring this book text outdated quickly. But I will hint some example of quirk that has been true at various point, found at various point in different JavaScript console environments to reinforce my point about not assuming native JavaScript behaviors while using them. So, for example, is whether a var or function declaration is a top level and global scope of the console actually create a real global variable and mirror window property and vice versa. That is mind blowing. So if I do this in the console and say, hey, var global one, and say, is this goes to the global environment, to the global, is this, or will this be appended to the global object as a variable? And if I define now a function and say function global function global one, all right, and then I say here console log the global one, all right. So if I go to the global object, or I mean is the window, sorry, is I go to the window object, and then I try to have access to the global, look at this, global one, and then function global one. So that's a behavior that is not so okay. This is a behavior that not the okay, holy moly, here we go. Okay, it is not always JavaScript. So using console or read event print loop, read event print loop, right? Using a console or read event print loop in your browser developers or Node, in your browser's developer tools or in Node might be seen as a might be seen as a pretty straightforward JavaScript, as a pretty straightforward JavaScript environment to test, all right, but it's not the reality. But it is not the reality. Interesting. It is not the reality. Since developer experience, developer tools are designed to improve the developer experience, which is something that I am glad to enjoy, like auto completion, like auto completions and like auto completion of variables and property, auto completion of variables and properties. The reality is that Such tool doesn't doesn't have to adhere, doesn't have to adhere to the Java spec. And here is a couple examples of this. So one of them is this: whether a var or a function declaration is the top level global scope of the console actually creates a real global variable and mirror window property and vice versa. That's mind blowing here. So whether you create a var or a function, or a function at the top level or the global scope, it attach that of the console it attach of the console it attach a real global variable, a mirror window property, and vice versa. It attach a real global variable and attach it to, it will create a real global variable, and mirror window property and vice versa, and mirror window property and vice versa. The other is what happened with multiple let and cons declaration in the top level global scope. When you say let, what happened with multiple let and cons declaration in the top level global scope? So you say, hey, this is a var1, say var1, and let var2, and if you want to have access to, I think that is also something true that is attaching those there. Oh, it's not creating that. It's not creating that. What happened with multiple let and cons declaration in the top level global scope? So what happens to multiple, what happened with multiple let and cons declaration in the top level scope? The other is whether use a strict on one line entry, pressing enter after, enable strict mode for the rest of the console season, the way it will on the first line on a JavaScript files, as well as whether you can use a strict beyond the first line and still get strict mode turned off for that season. So, in other words, if you do, for example, here, say function strict test, all right, and then it's a use strict only for this function. Whether use a strict on one line entry, pressing enter after, enables a strict mode for the rest of the console season, the way it will on the first line of a JavaScript, as well as whether you can use a strict mode beyond the first line and still get strict mode turned for that season. So for example, if I say let, what if I say var1 with 2 is interesting because, okay, what about this? No, because he's assuming that, and I say variable 1 dividable 1, and it still doesn't throw any errors there. Okay, what about this? Okay, variable 1. So if I say use a strict, and then I say var3 is equal to 3. Use a strict. I can even define variables like that. How non-strict mode, this default binds work for function call, and whether an object global here use will contain expect global. How hosting cbook2 and scope and closures work across multiple line entry. Whether use a strict on one line entry, pressing enter after, enables a strict mode for the rest of the console season. Or not even enable that, because if I have this, use a strict, and then I create now, let's say some another variable, say variable 10 with variable 10, and it allowed me to create that. That's pretty mind-blowing, bro. That's pretty mind-blowing. So in any case, what the French do you think you're doing? And the other is this. The developer console is not trying to pretend to be a JavaScript compiler that handles your entering code. Exactly the same way the JavaScript engine handles a JavaScript file. It is trying to make it easy for you to quickly enter a few lines of code and see results immediately. These are entirely different use cases. As such, it is unreasonable to expect one tool to handle both equally. Don't trust what behavior you see in developer console as representing exact to the letter JavaScript semantics as this. Many faces. So, many faces. The many faces. The many faces says that you can now use several functional programming. The term paradigm in programming language context refers to a broad, almost universal mindset, how to, and approach to structuring code. Within a paradigm, there are a myriad variation of style and form that distinguish programs, including countless different libraries and frameworks that leave their unique signature on any given code. No matter what a program's individual style may be, the big picture division around paradigms are almost always evident at first glance of any program. Typically paradigm level exactly, but no matter what a program individual style may be, the big picture divisions around paradigms are almost always evident at first glance of any programs. Typical paradigm level code category including procedural, object-oriented, and functional programming. Paradigms are neither right or wrongs, they are orientations, they are series of steps how to guide and mold how programmers approach problems and solutions, how they structure and maintain the code. hmm Since JavaScript can adopt multiple approach, multiple approach or multiple approach mental models, or how to, because at the end of the day is that, or how to exactly how to write programs, how to approach problems and solutions. Exactly. Since JavaScript can adopt multiple approach mental models, or or how to approach to a program, how to approach to a problem, and the effective way to solve a problem is by understanding where it comes from. It's by understanding where it comes from, the source of this. So since JavaScript can adopt multiple approaches, mental models, or how to approach to a problem and a solution, Jesus, what the French toast happened? Okay. I'll be right back. I'll be right back. I'll be right back. And we are back. Okay. The term paradigm in programming language context refers to a broad, almost universal mindset and approach to structuring code. Okay, since JavaScript can adopt multiple approach mental model of how to approach a problem and a solution known as paradigm. Okay, known as paradigm. Right? So typical paradigm level code categories including procedural, object-oriented or classes, and functionals. So procedural styles organize code in a top-down linear progression through a predetermined set of operations usually collected together in a relative unit called procedures. Where OOP style organized code by collecting logic and data together into units called classes. Whether functional programming style organize code into functions, pure computations as opposed to procedures, and the adaptation of these functions as values. So here we're going to describe is this. Why not? The procedural. So they are typical paradigm level code category including this. So typical paradigm categories are the procedural style, organized code in a top-down, so procedural style, organized code in a top-down, organized code in a top-down linear progression, linear progression through a predetermined set of operations usually collected together through a predetermined series of collections or series of operations, operations usually collected together in a relative unit called procedures. Usually collected in units, in related units, which is pretty common of the OOP, called procedures. So the OOP, the object-oriented programming or classes, it say this is style, organized code, this particular approach of how you solve problems, how you solve problems, and how you approach to problems and solve them, because that's what it is. How it is. I think what has caused me the most is that, I think what has caused me the most is that how can I use this particular model that it seems that a lot of people actually use and they're quite good at what they're doing and yada 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 yada, and to understand a problem, to approach a problem and write a solutions for this, because I think this is that's my main problem has been here. That has been my main issue here with the object-oriented programming, and the techniques that they're using behind that, right? And the same for the functional programming, because most of the time we are using the OOP for the backend, right, as a way to represent all of this data and its logic into unit called classes. Okay, so this OOP style organized code by collecting their data and logic into units called classes here. But that's what it is, right? So I have now this particular problem, and this particular problem, it has now a way of how you can solve this, all right? Using now this particular approach of this how to solve this problem, where you're gonna gather is the data and it is functionality together for. So you know what it means? And the other is a functional style. Functional styles organize code into functions, pure computation as opposed to procedure. It organizes code into functions, pure computations as opposed to procedures. Okay, and the adaptation of those functions as values, and the adaptation of those functions as variables. All right. So far so good. Paradigms are neither right or wrong. They are orientations that guide and mold how programmers approach problems and solutions, how they structure and maintain their code. Some languages are heavily slanted toward one paradigm. C is procedural. Java and C++ are almost entirely class oriented. And Haskell is a functional program through and through, right? So there is no good or wrong approach. Okay, so their orientation, the guy how to programs approach problems and solutions. Exactly, there is no good or wrong approaches. They are orientations. Okay, they are orientations of how programmers should approach on how programmers should approach to problems and solutions. That's one of the things that struck me the most here with this particularly imposing approach of doing this. But again, it's not your fault that the word is what it is, but it's your responsibility to get it. That's why I'm actually doing this. So okay. So language like C are procedural. Okay, procedural. C++ and Java are almost entirely C and C++ and Java are almost entirely object-oriented, okay, or class-oriented. Class-oriented, okay. In Haskell and functional programming, okay, and Haskell is functional programming, and so on and so forth. All right. But many languages also support code patterns that can come from and even mix a match from different patterns. Let me see. Okay. Let me actually wake up here. Just stand up. Stand up. Stand up. Stand up for your life. Oh yeah. Stand up. Stand up. Don't give up the fight. Don't give up the fight. Anywhere. Stand up. Stand up. Stand up for your life. Oh yeah. Stand up. Stand up. Don't give up the fight. Don't give up the fight. Stand up. Stand up. Stand up for your life. Stand up, stand up. Don't give up the fight. Stand up, stand up. Stand up for your life. Okay. But many languages also support code patterns that can come from and even mix and match from different paradigms. So-called multi-paradigm language also offers ultimate flexibility. In some cases, a single program can even have two or more expressions of this paradigm side by side. JavaScript is most definitely a multi-paradigm language. You can write procedural, class-oriented, and functional style code, and you can make those decisions one line by line basis instead of being forced into all or nothing choice. So in other words, JavaScript can accept or allow all of this programming style with 2M, programming style in your code. All right. But again, it's all about to understand what is the problem that you try to solve, and if your problem is a computation, merely a computations, so a functional approach might be the good way to do it. However, if your problems requires you to describe the world, or to connect two different nodes, or allowed to do different pieces of code to communicate that, all right? If that is the case, so an object-oriented programming approach will be much better of that. But it's all about this particular problems that you want to use that, whether it's the object-oriented programming or the functional approach. So if I ask to Claude about this, okay, so it is safe to say that if my problem requires communication between two entities, okay, if my problem if my problem is about communication between nodes of data, okay, if my problem is about communication between data of nodes, okay, or entities, so if my problem is about communication between data of nodes, or I think when we fucked up was the layer of abstraction. Yeah, we have too many layers of abstractions. So if my problem is about communications between node of data, object-oriented or classes is the right is the good approach. However, if my problem require computation, a functional paradigm or a functional approach is more a functional approach is more is a good candidate. That need to maintain a state and interacting with each other through well-defined interface. The encapsulation of a message passing abstract OOP naturally maps to system where different components need to communicate and coordinate. The functional programming strength is in computation comes from the emphasis on pure functions, immutability, and mathematical reasoning. These qualities make it particularly powerful for data transformation, parallel processing, and scenarios when you want predictable, side effect free operations. That says the boundaries are always clear cut. Some computation problems benefit from OOP ability to model complex state machines or hierarchical relationship. Similarity to functional approach can be excellent for certain communication patterns, especially in concurrent systems. Especially in concurrent systems. Alright? Where the concurrency, unlike parallelism, is that things that happens, things that overlaps at a time. Hey, this one is this task, and this is another task, and this is another task, and then 10 seconds later, there's another task, so on and so forth. Where immutable message passing reduces complexity. Modern language often blends these patterns effectively, and you might use functional techniques for data processing pipeline while employing objects to represent the system communicating entities. The key is recognizing that these patterns are tools in your toolkit rather than a mutually exclusive choice. Oh, okay, 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 good, good, good. In your style code, backwards and forwards. One of the most fundamental principles that guides JavaScript is preservation. Oh, exactly. So once we look at the different the the different phases, so the different programming style is also the backward compatibility here. Many are confused by the implication of this term and often confuse it with a related but different term, forward compatibility. Let's set the record straight. Backward compatibility means that once something is accepted as valid JavaScript, there will be no future change to the language that cause that code to become invalid JavaScript. Code written in 1995, however primitive or limited it may have been, should still work today. As TC39 members often proclaimed, we don't break the web. The idea is that JavaScript developers can write code with confidence that their code won't stop working unpredictable because a browser update is released. This makes the decision to choose JavaScript for a program a more wise and safe investment for years into the future. And that guarantee is not a small thing because it comes with maintaining backward compatibility. Stretched out across almost 25 years of the language history, created an enormous burden and a whole slew of unique challenges. You have been hard pressed to find many other examples in computers of such commitment to backward compatibility. The cost of sticking to this principle should be not casually dismissed. Is it necessary creates a very high bar to include changing or extending the language. Any decision becomes effective permanent. Mistake and all. Mm-hmm. Exactly. Any decisions become effectively permanent. It's like a tattoo. There is no laser surgery removal tattoo here, bro. Not at all. Not at all, bro. So once it is in JavaScript, it can be taken out because it might break programs. Even if we really like to remove it. So for example, particularly things like what is the value of null that give you an object? It's like, what in the French toast? Anyway, so there are some small exceptions to this rule. JavaScript has had some backward incompatibility change. But TC39 is extremely cautious in doing so. They study existing code of the web via browser data gathering to estimate the impact of such breakage. And browsers ultimately decide and vote on whether they are willing to take the heat from users from a very small scale breakage weighed against the benefit of fixing or improving some aspect of the language. So many more sites and users. I really love when US people talk about getting into problems. They don't say that. They say is the heat. All right. Hey, I'm not willing to take the heat. Right. So, for example, stuff like that. It's like, hey, that'll be a heated debate. There will be a heated debate, right? Or anything that took any effort. En Spanish tenemos algo que decimos, eso va a costar que jode, ¿no? Eso va a ser un acalorado debate. No estoy dispuesto a recibir ese calor. Okay. No estoy dispuesto a recibir el calor de los usuarios. O ese calor. No estoy dispuesto a recibir el calor de los usuarios. Okay. On whether they're willing to take the heat from the users for a very small scale breakage weighed against the benefit of fixing or improving some aspect of that language. So many more sites and users. These kind of changes are rare and are almost always in corner cases of usage that are unlikely to be observable breaking in many sites. Compare backward compatibility to its counterpart, forward compatibility. Being forward compatible means that including a new addition to the language in a program will not cause the program to break if it were run in an old JavaScript engine. JavaScript is not forward compatible. Forward compatible. Being forward compatible means that including a new addition to the language in a program could not cause that program to break if it were run in an older JavaScript engine. However, JavaScript is not forward compatible. Despite many wishing such and even incorrectly believe the myth that is, HTML and CSS by contracts are forward compatible. So the tags and the classes that we're gonna use in this moment will not cause our programs to break in older engines. If you dug up some HTML or CSS written back in 1995, it is entirely possible it will not work or work the same today. But if you use a new feature from 2019 in a browser from 2010, the page isn't broken. The unrecognized CSS HTML is a skip over, while the rest of the CSS and HTML will be processed accordingly. It may seem desirable for forward compatibility to be included in a programming language design. Yeah. But it's generally impractical to do so. So imagine that you want to provide forward compatibility to a language. All right. So not only that the features that you implement here are not going to work. So the features that you implement in this version, in 25 and then 27, 26, 7, 8, 9, and 30, okay? And when you reach to 30, it's like you can ditch all of these previous behaviors, which will be great, all right, and then force people to actually use that. So this is forward compatibility, which will make which will make that. The problem is that because it's the platform, so the platform can say, hey, I'm forward compatibility, so everybody will have to comply to the spec on that regard. So if you make forward compatibility, you will definitely need to, as a JavaScript developers, force to know the new syntax and how it's going to impact your applications, all right, and then provide some maintainability to that. I think this is not practical because it involves is like, wow, that's not. It is impractical because it involves that any time that a new features appear, all right, and some older features are discarded, so you will have, for any new feature, for any new version of the ECMAScript, write an application, the same applications that match that, and then that same application that match 2025 and then 2026, and see what are those changes that, and 2027 and 8 and 9, and as you can imagine, the cost of this, perhaps given with large language model, it makes much more easy to do that up to a certain point. But yeah, holy moly. HTML and CSS by contracts are forward compatible, but not backward compatible. If you dug up some HTML or CSS written back in 1995, yeah, it may seem desirable for forward compatibility to be included in a programming language, but it's generally impractical to do so. Markup or stylings are declarative in nature, so it is much easier to skip over unrecognized declaration with minimal impact to others recognized declarations. But chaos and non-deterministic will ensure if a program language engine selectively skip statement or even expressions that it didn't understand, and it is impossible to ensure that a subsequent part of a program wasn't expecting the skip over part to have been processed. Though JavaScript isn't and can be forward compatible, it is critical to recognize JavaScript backward compatibility, including the enduring benefit of the web and the constraint and difficulty in place of JavaScript as a result. So JavaScript, it makes a lot of sense that JavaScript is forward compatible rather than it is on the. So it is understandable why JavaScript is backward compatible, not forward compatible, unlike HTML and CSS, where they are now declarative, all right? But if you have now a programming language, but chaos and non-deterministic will ensure if a program language engine selectively skip statements or even expression that it didn't understand, as it is impossible to ensure that a subsequent part of the program wasn't expecting to be skipped over part of the being processed. So all of this is to say that if you have now a programming language that is now forward compatible, so any new features or any new spec on that year, then the language in itself will have to figuring out is what what was the not only the language but also you as a developers will have to determine is what is um, the change that impact your existing web app that makes you now be on live again. And the same for the next year and the next year and the next year when the browsers update all of these different things. And not to mention that browsers, not all of them implement those features at different times. So as you can see, it's quite impractical to do that. Holy moly. And it is impractical because not only that you as a developer, you have to understand the spec, and so not only understand the spec, but also understand now how major browsers implement those spec. And because those browser implementations uh, are different in time. So Safari is Chrome or Chakra, they implement at different times. And you want to provide support for your users. Holy moly, it's becoming like a French toast nightmare. Okay. And this is jumping the gaps. Since JavaScript is not forward compatible, it means that there is always the potential for a gap between code that you can write that is valid JavaScript and the oldest engine that your site or application needs to support it. If you run a program that uses 20x16 feature in an engine from 2016, you are very likely to see the program break and crash. If the feature is a new syntax, the program will generally completely fail to compile and run, usually throwing a syntax error. If the feature is an API such as exist object.s, the program may run up to a point but then throw a runtime exception and stop once it encounters the reference to the unknown API. Does this mean JavaScript developers should always lag behind the pace of progress? Usually only code that is on the trailing edge of the oldest JavaScript engine, they need support? No, but it doesn't. But it does mean that JavaScript need to take special care to address this gap. For few and incompatible syntax, the solution is transpiling. Transpiling is a contribute and community invented term to describe using a tool to convert the source code of a program from another, but still on the textual source code. Typically, forward compatibility problems related to syntax are solved by using a transpiler. The most common one of them is Babel, to convert from newer JavaScript syntax versions to equivalent older syntax. So for example, like this is gonna convert that into this. So the original snippet rely on let to create block scope. To create block scope variables in both the if and else clause, which did not interfere with each other, and equivalent programs with minimal reworking that Babel can produce. Just choose to name two different variables with unique names producing the same non-interference outcome. So you may wonder why go through the trouble of using a tool to convert from newer to syntax versions to an older one. Couldn't we just write that two variables and skip using let work? The reason is it is strongly recommended that developers using the latest version of JavaScript so their code is clean and communicate ideas most effectively. Developers should focus on writing the clean new syntax form and let tools to take care of producing a forward-backward compatible versions of the code that is suitable to deploy and run on the older supported JavaScript engine. So all of this, all right? Because we talk about here is the backward and forward. We talk about here backward and forward. backward and forward, and jumping the gaps and filling the gap. Mhm. Backward and forward compatibility, since JavaScript is backwards compatible. Backwards, exactly. Since JavaScript um, is backwards compatibility. So backward compatibility means that code written in older JavaScript engines will be executed without any issue. Okay, so unlike CSS and HTML, where they are forward compatible, where they are forward where they were exactly. Unlike CSS and HTMLs, uh, they are forward compatible. Compatible. Okay. Forward compatible. And here is this. Backward compatibility, they are forward compatible. They are this descriptive language, exactly, that code written in 2015 or 2010 may not work properly in 2020 or in 2025, right? So the idea of this is ensure functionality of your programs. Okay, ensure functionality of your programs. Ensure functionality of your program. Even though that we as developers, it is recommended. Okay, it is recommended. Yeah, that's right. Mm-hmm. So even though that we as developer, it is that we as developers the community recommendation is to write code that is to write current code is to write is to write updated. So the community recommendation is to write updated code to ensure clarity, because is that to ensure clarity of ideas, of the expression of that, to communicate ideas clearly. The community recommendation is to write updated code to ensure clarity and intentions of ideas that need exactly. The community recommendation is to write updated code to ensure clarity and intention of idea when expressing via code, right? So to avoid ourselves to guarantee this backward, okay, so to avoid ourselves to guarantee this backward compatibility, we rely on tools that allow us to do that, like Babel, for example. This is jumping the gaps, and the other is filling the gaps, right? This is jumping the gap. And to guarantee now forward compatibilities, all right, and to guarantee now forward compatibility, we use now tools like sheens. If the forward compatibility issue is not related to new syntax but rather to a missing API method that only recently added, the most common solution is to provide a definition for that missing API that stand in and act as if the older environment has already had it natively defined. This pattern is called a polyfill. So polyfill is for ensuring future or forward compatibility, future syntax, exactly, is to ensure future APIs syntax. All right. Consider this code. Get some record, return a use promise for some data it will fetch. Show the UI spinner while we get the data, and then we're going to pass through this data flow to say pr.then render records, and if there are any errors, show the errors, and finally hide the spinner, right? So this code used an ES 2019 feature, the finally methods on the promise prototype. If this code were used in a pre-ES 2019 environment, the finally method will not exist and an error will occur. A polyfill for finally is this. So let me take a look at this, at the prototype of that, at this functionality, which is this, all right? And then I'm going to return now a promise, a chainable promise, okay, that is going to receive that value and then returns a promise that now resolve that function that I received as parameter here, and by the time that I resolve this, okay, I want to not only return the function here, because it's either returning is a success, okay, because it's either returning a success or it's either returning is an error. exactly, is handling is these two cases. This is only a simple illustration of a basic, not entirely spec compliant polyfill. For finally, don't use this polyfill in your code. Always use a robust, official polyfill whenever possible, such as the collection of polyfill and shims. Shims. I think this is quite interesting. This very interesting is to know that shims. What is the meaning of this? Shims. Una cuña. Ok, una calza. Mm-hmm. Shims. Mm-hmm. Shims. Or polyfill. Mm-hmm. That's very, very interesting. And to guarantee now forward compatibility, let's say an API, an API or a method that is not available available in browsers, in current browsers, but yet they are mm-hmm. Okay, let's say an API or a method. Let's say an API or method that is not available in current browsers, but they will. So, for example, in the case of finally, mm-hmm. But they will. This pattern is called a polyfill. A polyfill. A polyfill. aka shim. aka shim. So consider this code, right? Finally, it has been not implemented. This code used this particular feature, but finally has not been implemented. If this code is run on a browser that is using a pre-ES 2019 environment, finally will not exist, and the polyfill will be this, right? It say, hey, this is the polyfill, this is how things should be, yada yada yada. This is only an illustration and use now official polyfills. So this is an illustration. Always use an official polyfill. And then let's take a look at interpretations in WebAssembly and WASP. Strict speaking and define. Alright, let's take a look at this. So what is an interpretation? Okay, here we go. Here we go. What is an interpretation? So a long debate question for code readers. So far we have describing is not only is what's the name of JavaScript, where it come from, who made that, and how that was named, and who were the responsibles to put that name and the motivation behind that. That at the end of the day, it now assumes that whoever's going to use this tool, JavaScript, must know or must have is a basic knowledge of C language, right? In the case of blocks and stuff like that. And how now the trademark that even though that is not enforced and is quite frankly is unlikely to be, they do that, um, is the yeah, it's quite frankly they're less likely to do that at this point. So Oracle via Microsums that was acquired in 2009, where that company acquired AOL in that company acquired AOL. That AOL acquired now Netscape, the company that developed the first commercial browser, and since that acquisition was in November 1998. Uh, the idea is to understand the legal aspect and the legal implications of using now JavaScript. You don't have any implications right now of using the trademark, and how from the technical aspect we use now the ECMAScript, and how the ECMAScript, which is the language specification, is designed by a commit called TC39, which is a group of people that works in a variety of web companies industry. That it can, some of them come from browser makers or browser makers or device makers, for example, like Samsung, and they run some meetings. They run some meetings 2 months, which is usually hosted by the company where they work, and some of them receive some compensation from those companies to be part of this committed. And so by monthly they run this meeting, usually lasts 3 days, where they now not only accept is a discussion about different proposals, that it goes to pass through 4 stages that go 5 stages that go from 0 to 4. As a programmer, we're starting to count from 0, and those stages where these proposals or champions, they can now open the discussion, so it is free for you to be part of the discussion. But at the end of the day, is those who meet in those unions, or in those who gather at those meetings, when the TC39 commit happens, are they responsible to promote those proposals or stage. And when that champions goes way up to the top, onto stage 4, it can take from several weeks to years to make that happen. So because of this, and that this commit that enforce how now browsers should stick to the law, all right? But because of the reality of the web, and since now JavaScript has more than 20 year plus, and as well as the JavaScript engines, some of those engines can decide to not complain to the JavaScript spec due to the reality of the web. And a fun, interesting case is that whether the TC39 uh, say that you must conform to this spec, sometimes they also make some errors for. So, for example, when you want to know if that particular element is in these collections, they want to use now compare, but they quickly realized that there is a particular library that or framework that was using that, so that's why they changed that to include. And the other is another case, which is hey, which is a tragic comedy event that happened in the JavaScript community of the Smushgate, all right, or how now they the TC39 propose is to the flat method for the arrays, okay. But again, it turns out there was a particular framework in Germany that was using now that name, and not only that has cascading effects, because they were not only using that methods, but also is when they do that, they now involved in some dumb operations. So again, because that goes is a very interesting read, but that illustrates that how even though the TC39 actually made some errors, in the spy that they tell to JavaScript engines to conform to the law, some of them can opt to say no, despite despite the reality of the web, as well as some decision makings from there at the top level. Now, so the point of this is that even though this particularly mismatch that can happen, and there is an appendix on the spec that you can take a look, the appendix B, all right, that describe is how now it described in detail is this mismatch across different JavaScript implementations or engine. So because of this, and especially if you're going to use a developer tool, all right, so that you might you might think that this is now a straightforward way to test your JavaScript code. However, this developer tool was designed to one thing in mind, is to help developers to make their life easier when it comes to test their apps. However, this doesn't guarantee that the environment, the JavaScript that you think they are running that follow these JavaScript specs, there actually is a JavaScript compliant. Okay, so why is this? Because there are some cases that this is not what happened in JavaScript. So for example, is var and functions, when you define that, they're now attached to the global scope, which is the thing here is that this is something that is not is attached to the window objects. All right. And there's some other behaviors. So for example, like hosting, which is something that we're going to see that later. All right. And I think that I point that out here like this. So how hosting works across multiple line entries. And the other is the use of a strict, that when you use now a strict on one line entry, it now act as a user strict when you use that, when you put that on the top of the file here. Again, these small nuances is to understand that despite where you are running this, okay, and when you run this actually matters. And the question is that, well, how do we now make sure that our code will run as expected? What is the environment that can guarantee us that, you know. Uh, that's a very good question, okay? Because not only that, this environment, so you can use this Node.js for that, or the browser or the JavaScript spec. Uh, the thing here is you can use this for a small set of lines when it comes to run your code. So because of this mismatch in how now when we work with other different environments, all right, such as the server with Node.js or robotics or light bulbs, you name it, we need to make sure that we understand is this mismatch. So, for example, when we're using is now methods like fetch or get current location or get user media, they are only relevant to the browsers, as well as from the server. You have only specific method relevant to the browser. And the reality here of JavaScript is that despite all of these environments, the web is in practically the web is the reality that matters. And I would love to understand where these are coming from. And I think that is coming from the community. That actually, for example, there's a lot of people and authors that had written several books to describe that more in depth on that topic. But I think that it aligns to the common knowledge of the community, where they agree that despite despite the huge variety of environments, the web is the reality that matters, right? So, because this reality of writing JavaScript applications and how you can use that using different paradigms, that those paradigms are the way of how programmers or mental models or how programmers now solve, how programmers approach to problems and solutions. So we have now the procedural, right, which is something that it involved is describing is one line by line from top to down, using now a set of current utilities or functions known as procedures there. So unlike now the class or object-oriented programming would say, hey, let's go into now write our code that collect is the data and it is logic into one single unit called classes. And the other is the functional approach, would say, hey, let's go into now define some functions which are pure computations, okay? Which means they don't generate any side effects. Again, that go beyond the scope, but I know what it means. It doesn't generate any side effects, and therefore, if we want to derive now new states, we can pass those to a new functions, right? So this particular approach of how to approach to problems and solutions is something that is complementary here in JavaScript. So this complementation of those JavaScript, and when it comes to now guarantee that these particular codes actually are compatible across different or across different JavaScript engines and versions of different JavaScript engines, right? So JavaScript is known as backward compatibility. So the team, the TC39, actually they say that they don't want to break the web, which means that it is backward compatibility. So functionality or logic that you or code that you wrote in 1995 will still being used or will still work up today. All right. So, for example, Space Jam, 1996. All right. So some code that was written here, even though you can expect here and see that they were using now, for example, elements like center, which is of course deprecated. uh, but they're using now some script called here, right? And there was another, the policies. uh, and now the add is Google Analytics to that. Holy moly. And they're using now G tags for that. I think this is something new that they add to that. That is mind blowing. And similar to this, the policy of that. Policies of JavaScript. I think this is something more recent. Absolutely. Start date here. Expire this. So in any case, this is a specific code that they wrote here, but as you can see, well, is now the website is still working. Sitemap. You know, to describe is how to navigate to this. You know, you have games for that. And I think this is when they can go to this. I think this is... Oh, they were using is Shockwave. If your browser is equipped with the latest Shockwave plugin, you will see the concentration gain below. Oh, grand. And lineups, trivia, match the monster, fantasy basketball, Hoop-O-Matic, fantasy basketball. But I think they redirect that to another website. We are American largest digital and print publishers. Nearly 200 million people each month trust us. See what we're up to. Des Moines and Birmingham, Alabama. Okay. In New York. So in any case, so as you can see, is this. And as you can see, is this. And an image, but as you can see, is that. So that's what I bring here is the Space Jam, because that to me was like mind blowing, bro. Mind blowing here, and how now JavaScript guaranteed this backward compatibility. Okay, it's because of that. And now, because if the community now agree to write the latest JavaScript to express your ideas with clarity and to express the intention of your code with clarity by using this new syntax. So we use things like Babel or any transpiler, which is this is where the name comes from. Is that you're going to now convert from one high level language to another high level language, okay? And to do that, well, we need you to actually go deep into this, and so these transformations is using now Babel, all right, or any other library that actually do this transpilation. But Babel is the most widely common tool developed by Facebook. So unlike HTML and CSS, they are forward compatible, okay, which is going to depend on the browser implementations to use that, because HTML and CSS is declarative, and because of this nature and the forward compatibility says that code that you might wrote for or structure or classes, the appearance or the layout that you wrote for 2000 might not work in applications, or might be skipped over in newer versions of the language. So this, because to guarantee this backward compatibility, we use now things like Babel, and if to guarantee now the forward compatibility is that APIs or methods that we can now use the new JavaScript latest syntax, and because browser doesn't support that yet, but they will at some point from the spec that I mentioned, from the language specifications. So this particular patterns to provide now a definition from APIs or methods, future APIs or methods. Now it is known as shims or polyfills, and it is important to use now polyfills that are JavaScript compliant spec. Okay, so with that, all right, now we finally reach to one of the hot topic debated of JavaScript. If this JavaScript is compiled or interpreted, a long debated question for code reading in JavaScript. It is an interpreted script or a compiler program. The majority opinion seems to be that JavaScript is an interpreted scripting language, but the truth is more complicated than that. Again, the detail is on the nuance. For much of the history of programming languages, interpreted languages and scripted languages has been looked down on as inferior compared to compiled counterparts. The reason of this inferiority, all right, of the history of programming, of this interpreted on the scripting language, the reason for this acronymy are numerous, including the perception that there is a lack of performance optimization. And it makes a lot of sense here, as well as a dislike or certain language characteristic, such as scripting language generally using dynamic typing instead of a more mature statically typed language, which is interesting. Now the entire JavaScript ecosystem is moving forward to use now this statically typed language, for example, like TypeScript. Okay, and that's interesting because it's now making your programs JavaScript programs to be now a compile phase that exists now, a compile phase that when the code is executed by the compiler, we can make sure that there is no errors at runtimes. All right, but I think this is for more mature applications. If you want to develop a rapid prototype, you just actually love the dynamic nature of this. And then you launch a prototype to see if this fits, and that's great. Okay, so so language. This is one of the two main reasons why this language are considered inferior. First is for some undesired behaviors, like the dynamic typings, unlike the counterparts, which are more mature, statically typed language. And the other is that the interpretation language are seen as not performance, seen as not performance, or that there is a lack of performance optimization. That to me is our nuance. And that to me is irrelevant because look at this. Look at what JavaScript and of course TypeScript now has made this. It says, allow me to now look at this particular website as well as this another one, and now help me to understand and to self-educate myself about this, about the true nature of this. And I get it. For and I don't completely get it. And I am completely get it, bro. And I am completely get it, bro. Absolutely. So, because of this, all right, and the language are regarded as compiled, usually produce a portable binary representation of the program. And there is a lot of things that happen here. There's a lot of things to describe, to unpack here. Language regarded as compiled usually produce a portable binary representation of the program. So this program, which is a portable binary representation of this code that we wrote here, all right, that sits on disk, and when we execute that, is now the OS that reserves spacing memory on the RAM for that, and now let the CPU execute that instructions. And this is known as a process. Why I mention this? Because this is a very this is a Google interview questions when it comes to understand that, hey, do you really know what you're doing? What is this? Is to further dive deep into the knowledge of the computer science, right? So not only that, this is a process, and the process has a particular feature that they have now a fix. They on memory, this programs now have a fine. So now programs has a reserved spacing memory, which means that if a program misbehaves, it won't affect other programs, which is great, right? And again, it's because this is now programs are loaded by the OS on the main memory, which is this set of binary representations that are portable. And they say portable because you can now pass these programs and these binary representations, usually made by a compile language, and then you can now distribute that, right? And I think that's pretty mind-blowing, bro. I think this is pretty mind-blowing. And how now these processes, one particular feature that browsers, for example, like Chrome actually does, is when they create now a new tab, behind the scene is creating now a new process. And some example of the process is like program counter, or the counter register or the processor register, the stack, and because now all programs at least must have is a thread. It's important to understand now threads actually they are is the single unit of execution that is determined by the OS to pass down to the processes, to the processor. So these threads actually contain is the process, the program counter, the processor register, the stack, but since they live inside of the process, and the process have now a heap, which is this memory that that is shared across different threads. All right, and one of the issues of the thread is that if you have a thread if you have a misbehaving thread, that will affect is how that so that will crash the entire program. Okay, so how now a OS process this how do how now the OS actually process this process and threads, and it does that via a scheduler. So this is scheduler which now in the context of a threads, since it's going to save the state of the threads, and because they now share that is the memory, this context thread switching is way much more performance than the process context switching, which now has to not only is store the entire state of the program, as well as using now some as well as the virtual memory that needs to be used to let it on allocating or not. This process is known as the process of the computer is the process in, or the switch in and switch out. Okay, that's what the scheduler does: switch in and switch out process and threads. All right, and because this process of this context switching is something that is costly, there are now new alternative that for example, language like Go are exploding. One of them is Fiber and the other is coroutines. That is at the application level, the responsible at the application level to periodically yield those controls, to periodically yield the control and coordinate is when a particular set of instructions needs to be run. This is the story when it comes to describe what a program is, what a process is, and what a program is, what a process, and a threats, and what is the meaning of the context is of the context switching, all right, or the scheduler. Okay, so I mention all of this because that is very, very, very important to understand, because this will now allow us is to see that JavaScript has now not only a synchronous nature, which is something that we're going to do in this entire series of videos, but also an asynchronous nature. All right, so yes, so language are regarded as compiled usually produce a portable binary representation of the program that is distributed for execution later. Since we don't really observe what kind of model with JavaScript, we distribute the source code, not the binary form. That's exactly. Many claim that disqualify JavaScript from the category. In reality, the distribution model for a program's executable form has become drastically more varied and also less relevant over the last few decades. the distribution model for a program executable. To the question at hand, it doesn't really matter so much anymore what form of a program get passed around. This missing form claim and criticism should be set aside. The real reason is matter to have a clear picture on whether JavaScript is interpreted or compiled relates to the nature of how errors are handled. Mhm. So despite that this nature of the interpretation, which is a long heated debate about JavaScript, this is an interpreted or a compiled language, right? And for historical purposes, now we get that. We get why JavaScript or people in the community uh, look at interpreted language uh, look at interpreted language and scripted language as inferior because they are not as performing as the compiled parts due to the dynamic nature and also due to the dynamic nature and the performance optimizations. So regard despite that this language, okay, so despite that the language compiled or so a language regardless as compiled, so a compiled language that produces is a portable binary representations of that programs that can be distributed later. So for example, the browser, when you see that .exe, all right, or the .apk, or that IPA in the case of iOS. I'm not sure what is the extension of what is the executable extension of Linux programs of Linux, Windows, Android, and iOS, and Mac OS program. So this is a good question for this. So for Debian is deb, for portable application is .image, and for Windows is .x. It can be MSI, installer package, batch file, legacy. In Android is the APK. In the AAB for Android Apple bundle for Play Store distribution. In iOS is the IPA, iOS App Store. Apps are distributed through the App Store, not as a standalone. .app, .damage. No, this is not damage, but it looks like damage. PKA, okay. No extensions required for command line executable index. So .dmh, disk image file, okay, so disk image file and the .app. So all of these extensions now are executable code. Is binary representations of a program that was generated by a compiler language, but that target those specific architectures. That's interesting. Very, very interesting. So historically, a scripted language or interpret. So the real reason is that matter for all of this, right, is that to have a clear picture on whether JavaScript is interpreted or compiled relates to the nature of how errors are handled. Historically, scripted or interpreted language were executed in generally top to down, line by line fashion. there is typical not an initial pass through the programs to process it before execution begins. So for example, like this, it goes to line by line, is historically line by lines to execute that, right? Until it finally now has the final form. In a scripted figure interpreting and script execution. In a script or interpreted language, an error on line 5 of a program wouldn't be discovered until lines 1 through 4 have already executed. Notably, the error on line 5 might be due to a runtime conditions such as some variable or value having an unsuitable value of an operation, or it may be due to a malformed statement command on that line. So whether a malformed statement or an expression or an evaluation. Depending on the context, deferring error handling to the line the error occurs or may be desired or undesired effects. Compare that to language which do go through a processing step typically called parsing before any execution occur as illustrated. Exactly. Compare that to language which do go through a processing step. So for example, those programs that go through a processing step, which is parsing that, and then now it compiles that to see if there are any errors, and okay, and then it's going to create now the execution. Is going now to produce the binary files, or the binary representation of that program, so those statements, that is ready for the execution. In this processing model, an invalid command such as broken syntax on line 5 will be caught during the parsing phase before any execution has begun, and none of the program will run for catching syntax or otherwise static errors. Generally, it is preferred to know about them ahead of any doomed particularly execution. Exactly. So for catching syntax or otherwise static errors, generally it prefers to know about them ahead of any doomed partial execution. So what do parser language have in common with compiled language? First, all compiled language are parsed. So a parsed language is quite and always down to the road toward being compiled already. In classic compilation theory, the last remaining step after parsing is a code generation. In classic compilation theory, the last remaining step after parsing is code generation, producing an executable form. Once any source of program has been fully parsed, it is very common that a subsequent execution will, in some form or fashion, include a translation from the parsed form of the program, usually called an abstract syntax tree, to that executable form. In other words, parsed language usually also perform code generation before execution. In other words, parsed language usually also perform code generation before execution. Parsed language usually also perform code generation before execution. So is not that much of a stretch to say that in the spirit they are compiled language. JavaScript source code is parsed before it is executed. So it is creating now this parsing way. The last remaining step after parsing is code generation. Exactly. After parsing is code generation. But JavaScript here is a parse language, but it is compiled. The answer is closer to yes than no. The parse JavaScript is converted to an optimized binary form, and that code, okay, so this JavaScript file is now parsed into a converted an optimized binary, which is this abstract syntax tree that we are quite familiar with, or that you should know. Okay, and this abstract syntax tree is just a representation. That is a way of how machines organize. It's a way how we tell the machines to organize the code, okay, that we're telling to, and somehow is now internally manipulate the data and the logic that we're passing through via this token. So this is the parsing that happened. So okay, the parse language. So JavaScript is a parse language. The answer is closer, but it's so JavaScript is a parse language, but it's compiled. Exactly. So JavaScript is a parse language, but it's compiled. The answer is closer to yes and no. So the JavaScript JS is converted to an optimized binary form, to an optimized binary form known as bytecode. Okay. And that code is subsequently executed in the figure 2 here, and that code is subsequently executed, and the engine does not commonly switch back. Exactly. So the engine does not commonly switch back into line by line execution like figure 1. Exactly. The engine does not commonly switch back into line by line execution mode after it has finished all the hard work of parsing. So most language engine wouldn't, because that would be highly inefficient. To be specific, this compilation produces a binary bytecode of sort, which is then handed to the JavaScript virtual machines to execute. Instead of producing these portable programs that we can execute in that particular architecture, all right, whether it is on the Windows or on the Mac or in the iOS or in Android or in Linux, depending of the distro, all right. Because of that is this, holy moly. So some like to say this virtual machine is interpreting the bytecode. But then that means Java and dozens of other Java virtual machines driven language, for that matter, are interpreted rather than compiled. And of course, that contradicts the typical assertion that Java are compiled language. Interestingly, while Java and JavaScript are very different language, the question of interpreted and compiled is pretty closely related between them. Another wrinkle that is that JavaScript engine can employ multiple passages of just-in-time processing optimization on the generated code, post-parsing. So once it generates is the parsing, all right, and how it, to check the errors. Okay, one it generate the parsing to check for errors, all right, for a specific type of errors, for syntax error. Okay, which again could reasonably be labeled either a compilation. So once that is generated, the question is that is that fully generated? All right, JavaScript source code is parsed before executed. So the specifications require as much because it called for early errors, statically determined errors in code, such as a duplicate parameter name, to be reported before the code start executing. So those errors cannot be recognized without the code having been parsed. The question is, once any source program has been fully parsed, exactly, it is very common that its subsequent execution will, in some form or fashion, include a translation from the parsed form of the program. In other words, parsed language usually also performs code generation before execution. But in Java, JavaScript source code is parsed before executed. So JavaScript code is fully parsed, or is partially parsed, or so those JavaScript code is fully parsed, or is fully parsed before, exactly, is fully parsed so it's fully parsed before generating bytecode. The question is that how do you know about this? If it is, what is your, if it is, show me your sources. Exactly, you're looking at the V8 engine for that. Mm-hmm. Mm-hmm. Understanding V8 bytecode. Mm-hmm. Oh, look at this.
I'm a software engineer on the V8 team. We're in Munich, so it's not even that far away. If you're ever wondering what is Google developing in Germany, V8 is being built in Germany for the most part. V8 is the JavaScript engine in Chrome, and my work focuses a lot on performance optimizations for ES6 and ES Next features. And I'll talk to you about JavaScript engines now. Engines. Why would you care about engines at all? Well, if you have any JavaScript source code, then SpiderMonkey is in Firefox by Mozilla, and V8 is like. If you get a bunch of JSON over the net, not good, because you give so little information ahead of time, finish the compilation, and then run the code. We're mixing engines have is, they don't have one compiler, they have at least two compilers, where one of them is an optimizing compiler. Ahead of time, finish, have all this freedom when we use tree to generate machine code. It generates an abstract syntax tree, the conditions fail, go back to the basic code. Yeah, so you start with JavaScript source code, then the parser generates an abstract
So the
syntax
parser is
tree. I will
completely
not talk about
generated.
the parser because my
And
coworker
then
Maya will tell you.
Exactly. This JavaScript source code is now completely parsed. Okay? And this parsing is to do random error detection or static analysis. And then it goes to create now this internal representation for the computer, the AST, okay, that say, hey, now as a computer, I know what is all of this set of instructions, and I know you can think of this step like generating is all of the different boxes, all right, and inside of the boxes content ready to be you can think of this EST is like the kitchen ready for now the chef and the teams get ready to do their magic, right? So that's very interesting because now it goes past through the baseline compiler here. And this base compiler now, it say, well, I'm going to, some of them translate to machine code and some of them I'm going to run some optimizations for.
Everything about how you can parse JavaScript or how we parse JavaScript and how you can write it to make it a little faster. So the source code is consumed by the parser and then we generate an abstract syntax tree. And then a compiler is using that abstract syntax tree to generate machine code. And we keep running that machine code, collecting information, and then we pass it on to the optimizing compiler to generate faster machine code. And every once in a while, we have to bail out, de-optimize, do an OSR exit to go back to the slower baseline machine code. So in the V8 engine, the faster machine code. In relation to cars, it's about the compiler pipeline in V8. It used to be full cogen and crankshaft, but we just switched that out. So turbofan and ignition are your new friends that make Chrome and Node fast. Legit. De-optimize a lot. De-optimization always means a small performance hit. All right, so far the high-level concept is machine code for this on an Intel processor. Property access, know anything about it?
Okay. Bytecode is an abstraction of machine code. It's closer to machine code, but it's not. So that is generating by that. And that was holy French toast almost 10 years ago. Okay, that's good. All right. And to be specific, this compilation produces binary bytecode or sort of that, which is then handles to the JavaScript engine machines to execute some like in some of them. So to execute some of this, and then it also now runs some optimization of those compile, all right, in those compilations for that. So interesting, while Java and JavaScript are very different language, the question of interpreter and compiler is very closely related between them. Another wrinkle is that JavaScript engines can employ multiple paths of just-in-time processing and optimization on the generated code, post parsing. So after it parsed that, it can now process or perform some processing optimization, multiple processing optimizations of that parsing on the generated code, post parsing. And of the generated code is this. After the generated, exactly, after the generated code, all right, after the generated code, interpreter injection and compiler turbofan. So after the code is generated, it can now pass multiple runs on that, which again could reasonably be labeled either compilation or interpretation depending of perspective. It is actually a fantastically complex situation under the hood of a JavaScript. So what do these nitty-gritty details boils down to? Step back and consider the entire flow of the JavaScript source program. After a program leaves an developer's editor, it gets transpiled by Babel. Usually, if you want to make your code backward compatible, it is transpiled by Babel, then packed by Webpack, usually, all right, and perhaps thousand other build processes, whether it's Vite or SWC, but it's packed by Webpack. Then it gets delivered in that very different form of a JavaScript engine. So the JavaScript engine takes that, parse the code into an abstract syntax tree, all right, and then the engine converts that abstract syntax tree into kind of a code binary implementation or intermediate representation, which is then refined and converted even further by the optimizing JavaScript compiler. But again, then the engine converts that abstract syntax tree to a kind of bytecode binary intermediate representation. Once it converts that, is then refined and converts that by the just-in-time compilation for optimizations. And finally, the JavaScript virtual machine execute the code. To visualize those steps, again, will be something like this. 1, 2, 3, and 4. Is JavaScript handled more like an interpreter, line by line, as in figure 1? Or is handled more like a compiled language that processes in one to several passes first before execution, as figure 2 and 3? I think it's clear that in the spirit is not in practice. If it's not in practice, JavaScript is a compiled language. And again, the reason the matter is since JavaScript is compiled, we are informed of static errors such as malformed syntax before our code is executed. And that is substantially different interaction model that we get with traditional script programs, and arguably more helpful. Yeah, arguably more helpful. And then we look at the WebAssembly. One dominating concern that has driven a significant amount of JavaScript evolution is performance. Both how quickly JavaScript can be parsed, compiled, and how quickly that compiled code can be executed. In 2013, engineers from Mozilla Firefox demonstrating a port of the Unreal 3 game engine. A port of the Unreal 3 game engine from C to JavaScript. The ability for this code to run in a browser JavaScript engine, okay, this engineer from Mozilla Firefox demonstrated a port of Unreal 3 game engine from C to JavaScript. The ability for this code to run in a browser JavaScript engine at full 60 frame Okay. Performance was predicated on a set of optimization the JavaScript engine could perform, specifically because the JavaScript version of the Unreal Engine code used a style code that favored a subset of the JavaScript language, named AS.js. This subset is valid JavaScript reading in ways that are somewhat uncommon in normal coding, but which signal certain important typing information to the engine that allow it to make key optimizations. AS.js was introduced as one way of addressing the pressures of a runtime performance of JavaScript. But it's important to know that AGSM.js was never intended to be code that was authored by developers, but rather a representation of a program having been transpiled from another language such as C, where these typing annotations were inserted automatically by the tooling. Several years after, ASM.js demonstrated the validity of tooling created versions of programs that can be processed more efficiently by the JavaScript engine. Another group of engineers, also initially from Mozilla, released WebAssembly. WAS is similar to ASM.js in that its original intent was to provide a path for non-JavaScript programs, C among others, to be converted to a form that could run in JavaScript engine. Okay. So not only that JavaScript code that I want to run here by the engine, but also is any other languages that when you transpile to this WebAssembly language, all right, it allows you to run that code by the JavaScript engine. Okay. So unlike ASM.js, choose to additionally get around some of the inherent delays in JS parsing compilation before a program can execute it, by representing the program in a form that is entirely unlike JavaScript. WAS is a representation format more akin to assembly, hence it is named, that can be processed by a JavaScript engine by skipping the parsing and the compilation. Interesting. So that is now a closer representation to the what the JavaScript engine machine. The parsing and compilation of a WASP targeted program happen ahead of time. What distribute is a binary package program ready for the JavaScript engine to execute with a very minimal processing. An initial motivation for WASP was clearly the potential performance improvement. While that continues to be a focus, WASP is additional motivated by the desire to bring more parity for non-JavaScript language to the web platform. For example, if a language like Go supports thread programming, but JavaScript, the language, does not, WASP offers a potential for such a Go program to be converted to a form the JavaScript engine can understand without needing a threads feature in the JavaScript language itself. In other words, WASP relieve the pressure to add features to JavaScript that are mostly exclusively intended to be used by transpiled programs from other languages. That means JavaScript features developed can be judged by TC39 without being skewed by interest or demand in other language ecosystems, while still letting those languages have a viable path onto the web. Another perspective on WASP that's emerging is interesting, not even directly related to the web. WASP is evolving to become a cross-platform virtual machine of sort, where programs can be compiled once and run in a variety of different system environments. So WASP isn't only for the web, and WASP also isn't JavaScript. Ironically, even though WASP runs in JavaScript engine, the JavaScript language is one of the least suitable languages to source WASP program, with because WASP rely heavily on static typing information. Even TypeScript, ostensibly JavaScript plus static type, is not quite suitable as it extends to transpile to WASP through language variants like AssemblyScript or attempt to bridge the gap between JavaScript and WASP. This book isn't about WASP, so I won't spend much more time discussing it, except to make one final point. Some folks have suggested WASP point to a future where JavaScript is excised from or minimized in the web. These folks often harbor ill feelings about JavaScript and want any other language, to replace it. Since WASP lets other language run in a JavaScript engine, on its face, this isn't an entirely fanciful. On its face, this isn't an entirely fanciful fairy tale. But let me just state simple. WASP will not replace JavaScript. WASP significantly augmented what the web, including JavaScript, can accomplish. That is a great thing, entirely orthogonal to whether some people will use it as a escape hatch from having to write JavaScript. So we talk about WebAssembly, and WebAssembly is a way to allow other programs, so programs reading in other language rather than JavaScript, to be run by a JavaScript engine. Mm-hmm. Mm-hmm. So was a so was is a language that there that yeah so what is a language primarily to okay so was is a language primarily to run language to run programs in compiler in compile based language using a JavaScript engine. Therefore, being able to be executed in host environments like the web, like web browsers, right? It's a compilation target and runtime format, not primarily a language in itself. WebAssembly is a binary instruction format for stack-based virtual machines, compilation target, portable by code and language agnostic. It is not tied to JavaScript. Key correction to your understanding, not just for JavaScript engine. While JAWASP can run in JavaScript environments, okay, it is designed to run in any host environment that support it, including not depending of JavaScript engine. WASP has its own virtual machine specification in browsers. It's run along the JavaScript engine, but use a separate was runtime. Direct compilation target. Language compiled direct to was bytecode, not through JavaScript. Via ECMAScript or CLAN, via WASPack, or via TinyCode. The real purpose, WebAssembly was created to bring near-native performance to web applications, allowing existing codebase to run on the web and provide a secure and sandbox execution environment. Exactly. We are very lazy people that we definitely don't want to rewrite or do all of that kind of stuff. But what we can do is to take, for example, COBOL application or C applications, all right, and then convert them into this universal performance language, into this universal performance program that can be run in any environment as a universal compilation target and runtime. Holy moly. So that'll be all for this video. Take care. Bye bye.